Good morning, everybody. We're Team 4, call ourselves Team Aviary. I'm Ben.
I'm John.
I'm Josh.
I'm Shaza.
Okay, so for design, as engineers, we oftentimes make very, very functional things that accomplish a task and have a very designated goal. And toys get away from that a little bit. We wanted to go all the way. Since we make so many functional things, we want to go the complete opposite direction. So we decided to make art. So we made a sculpture, and it has to be moving. So we decided it has to be kinetic sculpture. And we just started thinking about different forms and functions that can have, and beautiful movement. And we decided that birds, with their flapping and moving up and down, there's a lot of fluid motion, and we thought it'd be a really fun challenge to try and design some sort of mechanism that could mimic this motion that birds create when they fly.
So in terms of our goal is to exhibit and to inspire. So behold, Bobby the bird. The main point is when we during the first few weeks of the semester, I remember the professor mentioning about how a simple wind-up toy has a complex mechanism within the toy itself. So that's why we decided to exhibit, to expose the mechanism of the bird, like the gears and the motors and the belts behind the bird. If you can see it here. And then, and we also want to inspire we want to inspire children the beauty behind a simple mechanism of a bird. And then next, for our play value, it's fairly neutral in terms of level of restraint and gender. And then involvement is pretty much passive. Social involvement is solely and is a mental instead of a physical play value.
Alright, so I'm going to talk a little bit about some of the subsystems we have here. So one of the first things we did after we make the skeleton model was set a requirement for our RPM to have the speed not too fast, not too slow, and then basically we have to size a motor and design a gear train that's going to achieve that motion. So here is our motor assembly. This is on the back here, you can kind of see. And we have a motor which puts out 100 RPM based on 12 volts, and on the back side we have 2 gears and a pulley that's going to reduce that 100 RPM to about 30 RPM, which is what we're looking for. And yeah, so the pulley moves the outer gear, which is connected up to the front, so the gears in the front. And these are the gears that are kind of setting the wing motion. These are up front and exposed to kind of give that aesthetic appeal. And they have pins here that these rods can fit on to go into the outer wings.
So then this is the motion that the wings create, and it is a kind of funky 4-bar mechanism. Instead of, so like this would be the input gear, but instead of having this be 2 links, it's just 1 link that changes length. So with that, we get just 1 degree of freedom, and the only input is from this gear that is driven by the motor, and we can change how fast the bird goes and all this stuff. And we spend a lot of time kind of just playing with all these different lengths to try and get an actual motion that looked like a bird flapping its wings, because it's very natural fluid motion, and putting just numbers everywhere on it and getting it down into 3 or 4 links was kind of an interesting process. And then after that, birds obviously don't just flap their wings, they also move up and down. So we figured that if we attach strings to the wings of the bird, that would actually move the body up and down the whole time. So when you think about a bird, it flaps its wings, it doesn't stay in just a completely horizontal line, it moves up and down. Every action has an equal opposite reaction, as we all know. So we decided that simply attaching some strings, that creates a lot of fluid motion, and also hanging the bird makes it much less rigid. So everything is moving, it translates a little bit side to side, it kind of makes it much more natural, which of course is what we're always trying to strive for in this kinetic sculpture.
Alright, and so putting this all together in our CAD model, except for the up and down motion, just for clarity's sake, we have this functioning in its full entirety. And so the main difficulty getting this model in Creo was actually getting some of the parts to link up the way we wanted them to. One one trick being these little sliders here were a little tricky to make them cooperate since it wasn't a snug fit. We had to do a little bit of a finagling there, but we got it to work, and we can actually do a physical demonstration now for you guys. We got the video on the next slide if this doesn't work out. You guys ready? And so we've got as opposed to full up and down motion, just due to the weight of our motor, we had to do a little bit more of a tilting motion with the bird moving up and down, but the wing structure actually ended up working a lot better than we thought it would. And so there was a little bit of oscillation, but everything for the most part works as planned. So with that, we'll open up the floor to questions. Yeah, it's video.
So you mentioned that the weight of the motor caused the tilting, not the lifting, right?
Mhm.
So I just wonder what parts of the current design can be further optimized for the smaller form factor.
So one of our big constraints with this model was size. We were supposed to stay within a cubic foot build volume, which I think it does if the wings are folded in. But definitely with an actual model, we would make this a little bit bigger so that the structural integrity of the wings was a little bit better. Because just given that the wings are made of the more brittle 3D printed material, so they can't actually withstand a ton of load. So ideally, you would hang from the tail and the wings and just have that move up and down on its own. But due to just the brittle materials that we had to use for this design, it wasn't actually able to fully support itself.
Yeah, it was brittle enough that we dropped one of the wing segments and it fractured in half. We had to glue that back together, so we especially didn't want to load that piece too much. But the motor turned out larger than we thought it was going to be, and we just wanted to play it safe.
We've hung it from right here too, which is taking most of the weight.
That is
heading over.
the motor mount.
So it's angling up and down instead, and not taking a lot of force up in these wings.
And still creates a quite, a motion that does resemble up and down with flying.
More questions? All right. Thank you.
Thank you.